All right, guys, today we're going to be talking about dilations and sequences. So a dilation produces a figure that is similar to the original figure given. All right, it is either a reduction or an enlargement of the original figure. So you're writing reduction or enlargement. All right. The scale factor, we call that K. So K is just a number. That tells you how much larger or smaller the dilated figure is compared to the original. So in a reduction, the scale factor, so your K value, is between 0 and 1. All right, so K is between 0 and 1. So it could be 1/2, 1/3, 1/4, 2/3. You get the point. In an enlargement, the scale factor is greater than 1. So our K value is greater than 1. So 2, 3, 4, 5, you get the point. So in example 1, we are going to dilate triangle ABC with a scale factor of 2, so that's your K value, using the origin as the center of dilation. I want you to highlight that or underline it, whatever you have with you is fine. So you're using the origin. So the method we're about to use here can only be used when the origin is our center, okay? So first and foremost, we're going to find A, B, and C. We're going to find those original points, all right? So point A is at -2, 3. Point B is at 3, 5. And point C is at 4, 2. Okay? So there's our original values. All right? Since the origin is the center, we can take all of these original points and we can multiply them by the scale factor, which is 2 in our example. So all of these points we're going to multiply by 2. We're going to multiply the x value and the y value. All right, so our original point A was at -2, 3. So if we multiply that -2 times 2, we get -4. And if we do 3 times 2, we get 6. So that means A prime is at -4, 6. So we're just going to do that to B and C as well. So B prime is going to be at 6, 10. And C prime is going to be at 8, 4. Okay? And that's all we have to do. Now we're just going to graph it super quickly. So there's A prime. There's B prime. And there's C prime. So let's go ahead and connect those dots to make that triangle. Okay, and that's how we dilate a figure when its origin is the center. Okay? In example 2, it says dilate rhombus JKLM with vertices J at -10, 2, K at -2, 8, L at 6, 2, and M at -2, -4, with a scale factor of 1/2. Okay, so since the scale factor is 1/2, that means our image is going to get smaller. And we are going to use the origin as the center. So that's really good for us. We can use that rule that we just talked about, okay? So notice how our scale factor is 1/2 here. All right, so you can either multiply all of your original coordinates, so J, K, L, and M. You can multiply by 1/2, or another way of saying that is dividing it by 2. Okay, so we're just going to divide our x value and our y values for all of those 4 points by 2. All right, so that means J prime, if we're looking at point J, it starts at -10, 2. So if we divide both of those numbers by 2, we get -5, 1. All right, we're going to do the same thing with K prime. So -2, 8 is the point we're starting with. -2 divided by 2 is -1. And 8 divided by 2 is 4. Okay, I'm sure you're getting the pattern at this point. L prime is going to be at 3, 1. and n prime is going to be at -1, -2. All right, so we're going to take just a few moments. We are going to draw the original rhombus and we're going to draw our new rhombus as well, just so you can see what's really going on here. All right, so take a second to do that. I'm going to do it as well. All right, so here's my original rhombus. All right, it's not perfect, but it's something. And now we're going to draw our new image. Cool. And there we have our new image. Okay, so notice it shrunk, and it shrunk by a factor of 2. So the dilation was 1/2. It got smaller. All right, so again, we can do that because the origin was the center. We are allowed to do that because the origin was the center.